So what we're going to do right now is, if you participated in the midterm review session, it's going to be very similar. I'm going to do a really, really quick whirlwind tour of the entire class. So 13 weeks, 12 weeks of actual coursework. I'll leave some time for questions at the end. But basically what we're going to do is I'm going to highlight the most important salient pieces of information in terms of topics and subject matters that you really need to understand and feel like you understand well as a result of this class. Once you get that, the exam is going to be open book. The rest of your life is going to be open book. So you are going to have full access to all the materials as you study, as you take the test, and as you go on, whether you're going to be a researcher or not. So there's something that you need to memorize. But what I want you to do is just to make sure that you understand what the most important pieces of information are, so that we can just do what we can to make sure that when you go through all of these things that you need to go through, you know what to make sure you comment on. So from there, we will go ahead and start. Sorry, I'm going to try to mute folks so you don't get all the noise from other people's computers. Okay, so the very first thing that you did in the very first week of what we did was look at this whole issue of paradigms, theory, and research. And so a paradigm is the big picture worldview. Every researcher, yourself included, comes with some kind of worldview that's shaped by their history, by their background, by where they grew up, where they were raised, by their parents' worldview. So this is the underlying model or frame of reference we use to organize observations and reasoning. So if I view the world in a particular perspective, in a particular way, it shapes what things I see as important and also what things I choose to ignore. It shapes how I interpret things that I see, and it also shapes the things that I choose to not interpret because I'm just completely not seeing them because they're not coming to mind as important. And I think this is very important as you're looking at research, you're looking at studies, you're looking at study results, and most of all, if you're looking at the discussion section and looking at what conclusions a researcher might draw. And so the way that we can be quote-unquote objective is to really display or to let people know and be transparent about what your paradigm is. What we choose to look at shapes what conclusions we draw, because oftentimes we ignore things that may be very important parts of research, but we ignore them because we don't think they're important. So as we come into research with a particular paradigm or worldview, we also come to research with a particular model. And there could be a deductive model, which is a top-down approach, where you're looking big picture first. You're looking at theories. And based on a theory that you take, you generate some hypotheses, you make some observations, and you try to confirm or disconfirm your theory. You could come at research with an inductive model, bottom-up approach, meaning that you make a bunch of observations and you start noticing patterns. From these patterns, you generate some tentative hypotheses, and then from there, you generate some theory. In the real world, a lot of this is very circular, so both of these things tend to go on at the same time. You rarely will you find a scientist that only uses one particular model. So the piece that really drives what your research is your research question. It's a statement that identifies, or basically it's a question that identifies what you're trying to study. Now, a research question can be so broad that you could spend a whole lifetime researching it. And many people do. So if you have academicians who are scientists, they may spend their entire career looking at and trying to study a particular research question. A well thought out and focused research question, particularly for you as a student or as you start your journey into research, should obviously be interesting to you at least, if not to the general public. It should be researchable, so it's something that you can actually find some answers to. It should be feasible, not too broad for whatever you're trying to study. So if you truly are going into a career in research, you want to make your whole career focused on a research question, then obviously it could be pretty broad because you're going to be having sub-questions within it. But if you are at this point where you're trying to do a thesis or a dissertation, you want something that you can complete in like a year. So the more you narrow down the research question, the better you will be. And so with this research project that you all were given as an assignment for this group project, much of what I did the first couple of weeks after you started was to say, look, you need to narrow this down. It's too broad. There's too many things here. And I think that is the typical response, is that people tend to think, oh, we want to look at everything but the kitchen sink. And if your project is 6 months long or 3 months long or a year long, you need to shape that so that it's a very narrowly defined research question. And it should lead directly into your hypotheses. And these are whatever predictions you would like to make about the phenomenon you're trying to examine. So a hypothesis, and you really should know this very well by now, specifies or describes the relationship between variables in such a way that the relationship can be tested empirically. So a good hypothesis is written as a statement, not as a question. So remember, your research question is a question, your hypothesis is an actual statement. It's a statement of prediction that anticipates whatever results you think you'll find based on your lit review, based on your observations, if you're observing some things in nature, based on some theory that you may take. So it takes a clear side. It should be simple and concise and use clearly defined terms. It should obviously be testable. It can be shown to be either true or not true, and should be clearly connected to the research question. Now, a single research study may have one hypothesis, or it could have 3, 4, or multiple hypotheses. You can also have a study that does not have any hypotheses, and these would be your exploratory studies. For example, you don't quite know what you're trying to study yet. You're trying to explore what things are out there. And so let's say you're looking at dorm life in VCU college dorms, and you think there's got to be something really interesting that happens in dorms, but you're not quite sure what it is you want to study yet. So you may do a little study or a survey, or you may walk around the dorm and just ask people with interviews, what are some interesting things that happen in this dorm? What are some things that are interesting to study? What are what are the 3 most memorable things that happened this year in this dorm? And so you're just collecting and exploring things. In that case, you're not testing any kind of hypothesis, though you have a research question, which is, what are interesting things that happen in college dorms? So as you look at a hypothesis, obviously a hypothesis has to contain variables. A variable is an observable characteristic that has more than one value. So if you have an independent variable, it's what you or nature would manipulate to create some kind of change. Your dependent variable is what is impacted by your independent variable. And then you have what's called control variables, something that could be related to both your independent and dependent variables, and that you want to hold constant in order to mitigate problems with extraneous variables becoming confounding variables. An example of this might be, let's say you're doing something in a college dorm, and you want to look at the impact of, let's say, mixed gender restrooms, just to take something of common, I guess, modern day relevance right now. So let's say that there's a proposal now to say all restrooms are going to be mixed gender. It doesn't matter, and so therefore we want to see the impact on males and females of mixed gender restrooms, and whether their attitudes might change or not. Well, you might want to control also for obviously you want to control for gender, because males and females will see things differently, and that might be an impact. But you might also want to control for sexual orientation, because people who are homosexual may have a very different perception of mixed gender bathrooms, or someone who's transgender, you might want to take a look at that as a control variable. That might have an impact on their attitudes toward mixed gender bathrooms. So those are some things that could potentially have an impact on whatever perception you're trying to measure. So you want to hold them constant. That doesn't mean you're not going to measure them. You are going to measure them, but you want to say, all right, I'm going to take all the homosexual people and hold them constant and see if their attitudes are different than non-homosexual people. I may hold constant, people who identify as transgender, and hold them constant and see if their attitudes might be different from people, whether they're male or female. And you might even just say, I want to see if males and females differ. And if none of them differ, then you can just lump them all together when you're doing your analysis. But if there are some differences based on gender or based on sexual preference or based on whether they're transgender, then you want to separate those out in your analysis so that you can say, this group is different from that for this particular reason. The reason that you want to hold things constant to test them first is, let's say that males and females differ significantly. If you lump them all together, not realizing that they differ, you might actually show that, whatever it is you're looking at makes absolutely no difference. And the reason it makes no difference is because, males may differ in one way, females may differ in a different way, but if you lump them together, it just kind of washes out any change. And so you're not seeing any change as a result. And so that's part of why you want to really control for some of these things. Hold them constant, look at them separately, and if you see no difference, lump them together. But if you see a difference, you need to discuss why there might be differences. So the relationship is basically what you say is the correspondence between whatever two or more variables that you're looking at. Obviously, if you're hypothesizing that one variable impacts another, you certainly don't want to have no relationship. Meaning that knowing the value of one variable tells you nothing about the value of the other. However, if you have a positive or direct relationship, it means that as one variable increases, the other one increases. Similarly, if one goes down, the other goes down as well. An inverse relationship means that as one goes up, the other goes down. And a curvilinear or nonlinear relationship means that they are related, but the relationship, if you plot it on a graph, is not a straight line. The common example of this is stress and productivity, and we've talked about this before. So for most people, if their stress level goes up, their productivity tends to go up. So if there is a deadline coming up, you work a lot harder and more intently on whatever it is you're working on. So your productivity goes up. However, if you have just 5 or 6 different stressors, and you just become so stressed, typically what happens is at some point your productivity will go down, because when your stress level gets so high that you can't deal with it anymore, you may just shut down completely, and then you can't do the work that you're meant to do. So if you plot that on a straight line, obviously it's not a straight line. It's the line may go up for a while and then it starts to go down again. So as you think about research process, this is the big picture of all the things that we've looked at in this class. So you start with, the whole lit review background. What is it? And it may be that the research is important because someone has asked you to research it. My boss wanted me to research it, and that's why it's important. Well, then why do you think he wants to research it? And so you start looking at the background. Then you start the research process, which is to define your research question. It could be defined for you because your boss said, I want you to research this. Or it could be something that you are very interested in because you feel like, somewhere in your background or somebody has raised something of interest. So you define your research question. You define then your hypotheses that come out of that research question. And then you look at what steps you're going to take to actually test your hypothesis. And the steps that it's going to take is going to lead you to a research design. Your research design looks at, and we looked at a number of research designs, but you looked at true experimental design, which is kind of the gold standard for a lot of research, particularly kind of scientifically driven research. There's the quasi-experimental design, and then there's the non-experimental design. In a true experimental design, you're using random assignment to identify your groups. Now, random assignment is different than random selection. Selection has to do with where your sample comes from. Design or random assignment explains what you're going to do with your sample once you have your sample. And so in random assignment, you're basically, let's say you have 100 people in your sample. You basically want to have half of those people in a control group that will get some, no experiment, so no application of whatever it is you're trying to create. The other group will get some kind of experiment or some kind of intervention. And how you divide them is your random assignment. If it's divided randomly, so you're basically drawing names from a hat and throwing one into the treatment group and one into the control group, that's random assignment. If you're saying, I have these two groups, they happen to be classrooms, I can't divide up the kids in the classrooms, but I can say, these two classrooms look kind of alike, so I'm going to assume that because of demographics, they're probably close to each other. That's kind of a quasi-experimental design. And then you could have a non-experimental design. So you have no control groups, no multiple measures, and you're just trying to see, I'm going to give them all a survey, give them all some kind of intervention and see if there's anything that's potentially changes. It's a non-experimental design. So what we want to do is, in your research design, is to think about, can you meet the gold standard? Can you legitimately divide people up randomly? And many times, social research, it's very difficult to do that. In a lab setting where you're working with rats, it's fairly easy to divide up, the rats who get the treatment, the rats who didn't. But with people, it's very difficult. So there are very few truly randomized, true experimental designs of social research that are of high quality, that have the huge sample size needed. Much of social research happens in the quasi-experimental sphere. So you might have a pre-post, you might have two groups that you think are pretty close to each other, so one will get the experiment, whatever your treatment is, one won't. And then a lot of social research is non-experimental. So, we apply some kind of treatment and we just test them. And we say, what do you think? Did this impact you in some way? Or we just do a quick focus group and just say, you guys all experienced a particular item. Tell us about your experience. What do you think? So a very non-experimental design. So time comes into play in research design, in that your study could be cross-sectional, taking place at a single point in time, or it could be longitudinal, which takes place over time, where time actually has an impact. A cross-sectional design does not mean that it has to all take place in a particular hour or minute or even day. As I mentioned previously, census data is collected and it's cross-sectional, but the data is collected over the period of several months throughout the year. What happens in a cross-sectional study is that all that data is lumped together, and it takes place then in a single point in time in terms of, this is the data for 2010, or this is the data for 2020. So you're not looking at the difference between the data collected in January 2010 and the data collected in December 2010. So time is not a factor in your cross-sectional study. In a longitudinal study, time is expected to have some kind of impact or factor on that study. So essentially, if I'm looking at a pre-post study and trying to do an intervention, I am going to assume that over time something should change based on my intervention. So if I'm doing a smoking cessation study and I say I have this group of people, I'm going to put them through my smoking cessation class, and my anticipation is that those people who attend my class are going to be less likely to smoke or more likely to quit smoking. Then I'm basically saying that whoever is in my study, over time I'm expecting a change to take place. Now, a repeated measure study is one where you're taking 2 or more waves of measurement. They don't necessarily have to be regular intervals. But if you're doing a pre-post study, you might say, I have a 10-session class on smoking cessation. I'm going to take a measure prior to the start of the class. I'm going to take a measure after the 10 sessions. And then I might come back and look at them 6 months later, and then maybe a year and a half later or 2 years later, to see if that whatever change I predicted actually stuck. And so that could be a repeated measures design. Typically, people just do a pre-post just because it's easier. It's really hard to track people in a longitudinal design. But there are some huge studies that track people over the course of 2 years, 3 years, 10 years, even 50, 60 years. So those are still repeated measures design. A time series or trend design is where you have very regular intervals of data collection with 20 or more observations typically over a long period of time. Now, defining long could be just because you might be collecting data every single day for a year, so you would have more than 20 levels of data collection, or you could be collecting data every year for 50 years. Those are all time series, but it's because of you have that very frequent, regularly spaced intervals of data collection, and you have at least 20 periods of data collection that you're looking at. A time series design is typically used in policy research. If something happens to change policy, you want to look at, let's say the seatbelt law. Most of you were probably not even born yet when seatbelt laws came into place. But let's say what happens is, prior to a seatbelt law coming into place, you looked at the results of accidents and mortality due to accidents and the types of accidents that took place, and seatbelt behavior. So prior to a law coming into place, let's say only 5 or 10% of people use their seatbelts. So you look at the last 10 years of data prior to the law. You looked at how many people actually used their seatbelts, and then you looked at mortality and seriousness or severity of accidents. And then let's say you pass a law. You know that as soon as the law passes, you're not going to get 100% people using their seatbelts. You probably will never get 100% people using your seatbelts. But you want to collect data over the next, let's say, 5 years, 10 years, or 20 years to see if anything changes in terms of both seatbelt behavior and mortality rates due to accidents. So that kind of design is to look at the impact of that policy, but you'll have to look at it over a fairly long period of time to see what kind of impact that had. A cohort is a subpopulation who experienced the same significant event at a specific time period. So you could have a longitudinal study that doesn't look at the same people over time, but it could look at the cohort of people over time. So for example, if you had a group of people who experienced, let's say, the earthquake in Japan quite a few years ago now, and you think something about that earthquake might have impacted the mental health of these people. Maybe they have post-traumatic stress disorder, or maybe they have other issues. And so you might not be looking at the exact same people, but you want to look at a cohort of people who all experienced that earthquake, who lived in Japan at that time. And so you might say, I'm going to look at, in year 5, everyone who experienced the study or the earthquake are eligible to participate in my study. And then 10 years later, you might say, I'm looking for people who survived the earthquake, who were in Japan at the time. And then you might want to measure their mental health or mental status. So it may or may not be the same group of people that you looked at in year 5. It most likely will not be, but it's the same cohort. And you're trying to make some actual study conclusions based on that cohort. So now we also looked at sampling. And so you have research design in terms of your experimental design, and then you have sampling, which is also a design. So when you're addressing a research study, you are looking at a sample design, and then you're also looking at an actual study design or research design. And both of those have design issues that you need to take into consideration. In sampling design, this is who you're studying and how you get the people that you're going to study. So the theoretical population is who you want your study to generalize to when all is said and done. So if you want to generalize to all college students or all college freshmen in the United States, that's your theoretical population. The population that you can actually access is your study population. How you access them is your sampling frame. And then who actually ends up participating in your study is your sample. So if I want to give you an example, if all college freshmen in the United States is my theoretical population, How do I get access to college freshmen? I might say, well, I have this group of colleges throughout the United States who participate in a particular consortium. And so I can access them through that. So everyone who participates in, let's say, I'll just make up something, the East-West Coast, college consortium, they're my study population. So then I attend, a consortium members meeting, and I say, I'm trying to do this study in college consortiums. I have, 30 colleges who participate in this consortium. Will you let me access, your college freshmen? And let's say they all say, yeah, that's fine. We'll let you come access our college freshmen, all the college freshmen in this college. But there's one caveat. You can access those who are in your Psych 101 classes in all these colleges. So now how I can access is only freshmen who are participating in Psychology 101 classes. And so I go to all these Psych 101 classes and I recruit and I say, you're in my Psych 101 class. Your professor has agreed to give extra credit if you participate in my study. And so let's say 90% of those kids participate in the study. Now I have my sample. So in terms of the statistical part of sampling design, you have a variable, and that's the actual response that whoever participates in your study has, so the individual response. You have your statistic, which is what happens when you do your analysis based on your sample. And then you have your parameter. The parameter is what statistics you would have gotten if you had actually sampled the entire population, which is rare. So usually you talk about a statistic based on a sample and not the parameter. So there are a couple kinds of sampling. There's probability sampling and non-probability sampling. Probability sampling uses some kind of random selection. So a process or procedure that assures that the different units in your population have equal chance of being sampled or chosen. You have your simple probability sampling, which means that the typical random sample is what you tend to have. Throw every name in a hat and draw them out. You have a systematic sample, which means you order everyone in some particular order, whether it's alphabetical order or assign them a number. You start with a random start number, and then based on your sample size, you take every nth unit of that list. You have a stratified or proportional or quota sample, meaning that you take a simple random sample of homogeneous subgroups. So let's say you want to have, a good mixture of race and gender in your groups. So you might say, of the population I'm studying, let's say VCU students, and just for this example, VCU has 30% white, 30% African American, and then 30% all other races. So you might say, I'm going to take all of the African Americans and randomly draw a sample out of the African Americans. And I'm going to take all the white students and randomly draw a sample. And then I'm going to take all the other race students and randomly draw a sample out of that. And then I'm going to put them all together. So that's a stratified sample. A cluster area is to divide your population into larger groups that somehow make sense. So that could be, cities and counties. It could be voting districts or precincts. It could be people who live in particular census block tracts. But whatever it is, you're randomly sampling the unit of measurement, which is a cluster or an area. And then from there, you could be randomly sampling a subcluster or area. And then from there, you could be then randomly sampling individuals who live in those selected clusters. Non-probability sampling, on the other hand, does not involve random selection. And therefore, it's a little bit harder to generalize if you're using a non-probability sample. Now, it's not saying it's impossible to generalize, because if you have a purposive sample, like it's your judgment that you are picking people who have a particular expertise, you can generalize to those people, but you can't generalize to the general population. So in a convenience sample, you're basically sample who's available to you, which is why college students are used in a lot of research. They happen to be available, they're open to doing extra credit, and so it's very convenient to sample them. The man on the street interview is another convenience sample. So people who happen to be walking by you in the street or in the mall, you go, excuse me, can I take 5 minutes of your time? And if they agree, you sample them. So that's a convenience sample. They're people who are available to you and they're willing to take your sample. Purposive is based on your judgment, people who represent the population that you want to study, and you intentionally go after them. Quota is structuring a sample that's a cross-section of the population, but using a convenience and not a probability sample. So you might do the, hang out at the shopping mall and say, my population is 30% black, 30% white. So I'm just going to go around and ask people to participate in my survey, and I'm going to target, the white people that walk by, or the African Americans that walk by, or the Asians that walk by, until I get enough of a sample to meet my quota. But it's not probability sampling in that it's not random. And then a snowball is a referral sample. So I might say, I want to look at college freshmen, and I'm going to go talk to, 20 of my friends who are college freshmen. And then I'll say, can you refer me to 20 other of your friends who are college freshmen? And they could be going to school in different places, but obviously you graduated from high school with a group. And so, tell me the names of 20 other people that you know who are freshmen. And then you'll interview them. So we also looked at sample size, and there are some general rules of thumb. You're not going to have to ever calculate sample size by hand, so I don't ask you to have to know how to do that, but you should know the general rules of thumb when you're thinking about sample size. And you should be able to use a table that gives you a sample size table. So rules of thumb: accuracy, the greater the accuracy, the larger the sample needs to be, obviously. Confidence level: the more confidence desired, the larger the sample required. Population variability: the more diverse your population, the larger the sample size you'll need to capture the diversity. And obviously population size: the larger the population, the larger the required sample size. Now all of this comes with the caveat that at some point in time, increasing sample size will not increase your results by that much. In terms of your return on investment starts to decrease. So if you have a population size of, let's say, 1,000, getting a sample of 100 people, you might get a pretty good result. If you increase to 150, you might get a slightly better result. But at some point, possibly when you get to about 200, as you increase from 200 to 205 to 210, your return on investment is probably going to be pretty small because you already have a good, huge percentage of your population involved in your sample. So adding 1 or 2 or 10 more is not going to increase your confidence in the data. It's not going to change your data significantly. Measurement is another big piece in research design, and you probably have struggled with this in your group project, and so you should be pretty good at figuring out this measurement piece by now. But as you look at your hypothesis and you look at your variables, you then have to start asking yourself, how do I actually measure these variables? Typically, variables are conceptual, known as constructs or traits. This means that they cannot be directly observed and measured. The process of taking a concept and defining it in a way that's observable and measurable is called operationalizing your variables. So the example I gave here, and I also use this during the midterm review, is let's say I'm looking at the impact of religiosity on happiness. So my independent variable is religiosity. My dependent variable is happiness. Well, I can't just go out to the general public and go, I'm just measuring happiness. Because someone's going to ask you, well, how do you define happiness? How are you going to measure that? You can't just observe happiness in the natural realm. Just like you can't really observe religiosity. You have to define it in some way that makes it observable. So let's take my variable of religiosity. So I'm going to apply a conceptual definition. I'm going to say, in my definition, for my research purposes, I'm going to say religiosity means someone who's devoted to a particular religious belief. And then I'm going to take that conceptual definition and operationalize it. So I'm going to say, someone is considered devoted to a religious belief if they regularly read scripture, they pray, they attend religious worship services. So now I am operationalizing it in a way that makes it measurable, because I can measure regular reading of scripture, I can measure regular prayer, I can measure regular attendance at worship services. So then I take it to one step further and I say, okay, so how I'm going to operationally measure it. The way I'm going to measure it is I'm going to give them a survey and ask them the following questions. On average, how many days a week do you read scripture? On average, how many times a day do you pray? On average, how frequently do you attend religious worship services? Somebody else might measure it by saying, I'm going to observe, the 50 people in my study, and I'm going to watch them and see how often they read scripture. Or I'm going to ask their family members or friends. That could be another way to operationally measure it. Or I could take a composite score. I'm going to ask their parents, I'm going to ask their best friends, and then I'm going to ask them. And I'm going to create a composite score of all their responses. So those are different ways to operationally define and measure something that's a concept. For my purposes, for my study, I'm going to define high religiosity as someone who has, let's say, a combined score of 9 or more. So let's say for each of those measures, scripture, prayer, and religious worship, they're, let's say, rank ordered on a score of 3 or 0 to 3 or 0 to 10, however I want to do it. And so my combined score of 9 or more is high. My 5 to 9 is medium. 4 or less is low. So now I have values of my measures. We looked at the measurement and research design and levels of measurement, and this comes into play when you're looking at the right statistical or analytical tools. And for those of you who have taken statistics, you'll definitely know this very well. For those of you who are going on to take statistics either next semester or next year, just keep in mind that this will play a big role in what statistics you use. We've barely just brushed on some of the statistical and analytical pieces in your research methods course right now. But when you go into statistics, you will go into much greater depth with a lot more statistical tools. But in general, you have quantitative data and you have qualitative data. And that comes into play when you're looking at qualitative research design and quantitative research design. Quantitative data has to do with numerical values. And it is a way of looking at things where, let's say, you do some kind of scale, so a Likert scale. On a scale of 0 to 5, how would you rate this? Or on a scale of, or a weight. What is your weight? It could be, differences between how much money you spend or income level. But that is all data that reflects itself in a number. And so quantitative data can be either ratio or interval. It has a true 0 or it doesn't have a true 0. Qualitative data and ordinal data can be looked at qualitative or quantitative, but usually people use it as quantitative if it's some kind of ranking or order or scale, or like a letter grade. Nominal data is category, and it's not ordered or direction. So marital status. It could be, the type of car you own, your favorite ice cream. There's no particular order. It's just a categorical function. That's definitely a qualitative data. Obviously, people's recounting of stories or their way of explaining something will be nominal. In that you're just expressing things, your opinions on things, you're not ranking them, you're not putting them in any kind of scale, and there's no particular order to it. That's going to be nominal data. And so when you're looking at qualitative research design, you're collecting data that does not have any kind of logical ranking, order, measurement, numerical way of looking at it, and therefore your analytics is going to be based on or categorizing things, lumping them together in some kind of meaningful way, but not by analyzing them in terms of like correlations or frequencies. And so be thinking about that as you think about research design as well. So we looked at using secondary data in research, and this is often a great way to do a study if you have data available to you. There are a lot of data sets available, and they were not collected for the purpose of your research, but they may have the types of data needed to do your research. Obviously, existing data was collected for some other purpose, so you need to be a good consumer of data and make sure that you understand why that data was collected, how it was collected. Make sure that you're able to access the database and verify the content of the database. You need to ask questions about sampling design, because obviously if you're using bad data, or if you're using data that you think is giving you something that you're researching when it's really not, your results are going to be junk. If you're not using existing data, that means you're going to have to collect data in some way. And so we also looked at survey research and design, because survey research is one way to collect data, and it's probably one of the more popular ways of collecting data. Surveys can be done through questionnaires, and questionnaires can be done by mail or paper form, or by internet online form. It can also be used, gathered by personal interviews or telephone interviews. So these are in-person designs. We looked at different factors that contribute to a good survey, and we also did a food for thought question about, what are some things that irk people about surveys. Question wording is one of those things. How ambiguous or clear is the question? A lot of times, surveys, let's say I'm wanting to interview inner city African American students from the Deep South. Well, you're going to have to make sure that whatever wording you use matches what they understand, because there are all sorts of cultural, as well as geographic, as well as social, economic status impacts on what words people use. And if they don't understand it, they're not going to respond to it in the way that you intended for that to happen. And so the importance of pre-testing a survey on the target population cannot be emphasized enough. If you're going to develop a survey, please pre-test it on the population you plan on giving it to, because you may find some very, very interesting results, because they don't use your vocabulary, they don't use your wording, or they don't understand it. Wording can also be questionable or objectionable or threatening. And if people feel threatened by some kind of phrasing in your study, chances are good that it's going to create a response set, because they're going to get pissed off at you and they're going to respond in a certain way, or they're just going to stop taking your survey because they feel threatened by the questions being asked. So that's another issue that you need to be very careful of. Loaded, leading, biased questions, again, will skew your results if people think that you're looking for a particular answer. And so you need to be very careful about that. Question content. One of the biggest things I ask is, and as I read your food for thought, one of the biggest turnoffs to surveys is it was just way too long. There were too many items, and by the time I got past, 5 minutes or 10 minutes, I was done. I did not want to go on. And if I did go on because I felt like I had to go on, I didn't really think through the questions, I just answered, and many people would just quit. So how necessary is each item in your survey, and do you have a plan for analyzing the responses? A lot of people like to just throw things in because they think, oh, it would be interesting to ask this, or it'd be interesting to ask that, or wouldn't it be nice to know this? If that is not very targeted at what you're looking for as a researcher, and it has a very specific impact on your research design, don't ask it. It's not worth half your people quitting before they finish your survey, because now you have useless surveys. And it's also not worth people, halfway through going, oh, this is too long, I'm just going to randomly, put all B's or all C's. Because again, you have useless survey. Question sequencing and placement also plays a role in good survey research design. So you want things to group together, you want things to make sense, you don't want to just randomly jump around from topic to topic, because it makes it very hard for people to focus on what you're asking. Indices and scales are types of composite measures that might summarize or rank order observations. So an index is an accumulation of scores from a variety of individual items. So you might say, I'm going to create an index of what I think is religiosity, and I think religiosity is requires me to look at 4 or 5 or 6 different dimensions of religiosity, and also asks me to talk to your friends, your neighbors, your fellow, your peers, and I'm going to take this composite measure that ranks order a whole bunch of different observations. A scale, on the other hand, is a composite measure that's comprised of a couple of items. So I might say, I'm going to look at, whether you think you are religious, whether you pray a lot, and I'm going to take all those and create a composite measure, which is called my religiosity scale. So you also looked at evaluation research design, which is a particular type of research design that is looking at the impact of a particular program. So when you're looking at that, we looked at this concept of a logic model. The logic model is what frames or creates an understanding of why you implemented the program that you're implementing. And so you're looking at the situations, the context of the program, the priorities of the program, what you put into the program, so whether it's staff or volunteers, time, money, whatever it is that goes into creating a program that you're creating or studying. Then the outputs, what activities, what level of participation, who we want to reach. And then you can think about outcomes, whether that's short-term results, so it could be knowledge gained, it could be attitude change, it could be skills. It could be some medium-term impact, so change in some short-term behaviors, change in practice, or changes in decision-making, or even changes in policy. Then you could have very long-term impacts. So you could have changes in social conditions. You could have economic changes based on something that happens in the short and medium term. It could be civic engagement changes that you're looking at for, or ultimately 10 years from now it's going to have an environmental impact. So what are those things that you're looking for on the long term? You also have something called formative or summative evaluation. Formative evaluation is intended to help strengthen or improve your program and often focuses on process measures. So taking attendance is a formative evaluation because you want to see if people actually attended your sessions. If you have a 10-session class and only the majority of people only attended 3, you're going to have to explore, how do I get people to attend all 10 sessions? And you might want to explore, is attending all 10 sessions necessary to create change? So these are all things that would strengthen and improve your class. Summative evaluation looks at the actual outcomes. So what is the impact of all the people who actually attended all 10 sessions of your class or all 9 sessions of your class? What did it do to change their attitudes and their behaviors? In qualitative research, you're again looking at qualitative data. So not looking at numbers, but looking at understanding, trying to understand a group of people, what shapes their thinking, how they perceive things. And there were a variety of different ways to look at qualitative research. There's ethnomethodology, which you also looked at as a paradigm. A researcher wants to understand how a participant perceives or brings meaning to their personal experience. So how someone might interpret something that happens to them. So typically what happens in this type of research is you might do something out of the ordinary. You might go to a ball game and instead of cheering, you have someone fall asleep, or you have someone do something really bizarre. And then you ask the people around them, well, how do you interpret, why is this person sleeping in this ball game? Or, why is this someone, let's say, running around streaking naked through a ball game? And you talk to people, how do you interpret this? What did you experience? Why do you think this person did this? And you're really trying to capture how people participate and understand and lend meaning to their experience. You might also want to look at group behavior. Ethnography is a way to understand group behavior, looking at cultural groups. A case study might be, a significant, someone who, let's say, grew up in a very impoverished home, had really poor education, had all the things that you would say are risk factors for poor outcomes, and yet this person went to Harvard, went on to become, a Nobel Prize person. Well, you would want to do a case study on this person. What is it that made this person defy, all the results? So you're not going to be able to generalize, but you could certainly look at case study, talk to people, talk to them, talk to their experiences, capture their history, look at their biography, look at all their life experiences to see what shaped this, that made this person so different than everyone else. And so these are all just different ways to look at qualitative research. And there are whole entire courses devoted to qualitative research, so you really just got a snapshot based on those 2 or 3 chapters that looked at this on the different types of qualitative research design. One kind of qualitative research design is action research. And this is actually a combination of qualitative and quantitative because you're looking at numbers, you're looking at intervening. But what makes this different than your typical qualitative and quantitative research design is that you as the researcher actually become part of the group that you're researching. You're no longer the objective observer. You insert yourself into whatever group, oftentimes it's a marginalized group, and you become a voice. You bring a voice to that group. And the group is completely involved in the design of the research, the design of the outcomes, and the design of whatever intervention comes into play as a result of defining the problem. And so instead of the research scientist kind of being on the outside looking in, the scientist actually inserts themselves into that community, gets to know people really well, gets to understand these people, engages everyone into how do we design a research study to look at this, how do you define the problem, how do you define the solutions, let's test these solutions, how do you define success. And it's so entrenched in that community and that community being a participant in this that you as the scientist are really become part of that community as you insert yourself into this. And people are very excited about this model because it's really yielding some results that are related to policy decisions, related to community change, related to social change. And so this is one area where you as a researcher can insert yourself into a community and become a part of shaping change. One of the earlier things that you looked at was research ethics. And so I don't want to shortchange this because I think there's a lot to research ethics and there's a lot to very poor research because of bad ethical design. Some key things you really want to understand is what is informed consent, and that is comprised of a number of things. How do you identify and weigh the costs and benefits, because research ethics has to do with whether the costs outweigh the benefits. Whether the costs outweigh the benefits, in which case it is something that would have significant risks to a person and probably will not get approved by an IRB. Whether you have some unbiased selection of subjects, and whether you protect the privacy and confidentiality of the people who are participating in your study. And just to note that confidential is not the same as anonymous. Anonymous means that you as the researcher have no clue who responded to, whether it's a survey or you just don't know the people who are replying. Confidential means you can find out who replied or responded, but you have chosen to keep that confidential, whether it's by separating the names from their responses or assigning a number to the name and then just using the number in your analysis. There are different ways to keep things confidential. So the components of informed consent are you basically let people know you're doing research. They need to know that they're participating in research. They know the purpose of the study. They know the duration of the participation, whether it's an hour or 2 years or 10 years. They understand the procedures and they understand if there's anything experimental going on. They understand the risks, benefits, and alternatives. They understand your confidentiality of policy. They understand whether they're going to be compensated or not. They understand that it's voluntary, and this is a big one. And they also understand who to contact if they have questions. IRB review. There are 3 types of IRB, and you really should know what types of research qualify for what types of review. So a full board review is obviously for something that is more than minimal risk. It has risk to subjects. It's not covered under other review categories, and it involves interventions that have physical or emotional discomfort or sensitive data, for example, criminal behavior and people telling you about things that could put them at high risk if it's divulged to the public. Expedited review, there's 9 categories of expedited review, and these are not greater than minimal risk. Examples include like specimens that are non-invasive, like a saliva sample or a nail clipping or a skin scraping. Research with existing documents, survey research is typically expedited unless you're asking them very sensitive information. And then you have exemption review, which are things that are less than minimal risk, and they fit some of those exempt categories. For example, an anonymous survey when no one's at risk because you don't capture any of that information. So really kind of try to understand what falls into what category. Minimal risk just means that the risk of harm or discomfort anticipated is no greater than what you would encounter in daily life. So finally, I'm going to just look at real quickly at a couple things. I know we're running out of time, but looking at validity, is the research valid? And there are multiple levels of validity. There's validity in terms of generalizability to other populations, and that's external validity, and that has to do with how you picked your sample. There's construct validity, which is related to measurement. Is the construct that you're measuring measured correctly by how you chose to measure it, and can we generalize it, really generalize it to that construct that you're trying to measure. There's internal validity, which means that is the relationship causal. Did your research design was it able to demonstrate that your independent variable created change on your dependent variable? And then your conclusion validity, which is all of those brought together. Is there truly a relationship between cause and effect because you have generalizability, you have construct validity, you have internal validity, and it all comes together and you can actually say my conclusions are valid. We looked at a whole bunch of threats to internal validity being causation. And the threats really have to do with, are there other things that could cause an alternative explanation? So if your independent variable created a change into your dependent variable, is there an alternative explanation to it? Something happened historically that could have affected it. The way that your subjects were selected could have affected it. Maturation could have affected it. Statistical regression. So these are all threats to internal validity. Reasons that another alternative explanation could have happened. Experimental mortality or attrition that's not random can be a threat. Testing effects can be a threat if the initial testing caused people to go out and kind of find the answers that you're looking for, so that when you do the post-test, it's simply because they looked for the answers and not because of whatever intervention you gave them. Changes in your measurement instrument, oh, this wording was really bad, I need to change it in my post-test, that could be a threat. And design contamination. People know that they're being studied, so they act differently. Threats to external validity has to do with the generalizability piece. And so again, how your subjects were selected, the location or setting, if the reason that their responses were the way they were was simply because of the setting that they're in. And if you change your setting, you'll get different responses. That's a threat to generalizability. Recent events, history is also an external validity challenge. And then again, similarly with testing. So is the research reliable? Reliability, unlike validity, has to do with measurement, specifically to this type of measurement, and it's whether you would get the same or similar results over and over again, assuming what you're measuring hasn't changed. So internal consistency, if you say 3 or 4 different things measure the same thing, are your results showing that? Inter-rater, meaning if you have 2 observers looking at a particular object, like behavior in a classroom, and you're saying, are these kids well behaved? Does the teacher have control over the classroom? And observer 1 rates the teacher and says, absolutely perfect teaching, you know, really strong control over the classroom, and the second observer says, oh, absolutely not, this teacher is horrible, has no control of the classroom, you have a problem with reliability in terms of your inter-rater reliability. And then alternate forms, using two different forms that in theory measure the same thing, and hopefully you get the same score. For example, in your SAT or a lot of standardized tests, some people get the first form, some people get the second form. If you use the same test and use different forms, you hopefully still get the same or very similar results. The difference between reliability and validity is kind of looking at this target. You can be reliable but not valid. So your instrument is great. It measures exactly what you tend to measure, and every time you measure it, you get very similar results. But it's not valid because you're not actually measuring what you think you're measuring. It could be valid but not reliable, like asking someone what time it is that doesn't have a clock or a watch. Valid, yeah, you know, they'll come pretty close. They'll say it's morning or afternoon or it's around 3 o'clock, but it may not be very reliable. Could be all over the place. Obviously, you don't want to be the third, which is neither reliable or valid. And for a researcher, you want to be as close as possible to this fourth target, which is both reliable and valid. And then the last couple things we looked at were just descriptive statistics. You know, we looked at distribution, which is the summary of the frequency of values or ranges of values for a variable. We looked at central tendency, which is how things distribute across the center of a distribution, and we look at center meaning both mean or average, median, and mode. So 3 ways of looking at the center and how things distribute around the center. And then we looked at dispersion, which is how spread out these values are across that center. And so looking at the range and looking at standard deviation are ways to look at that. And then you looked really briefly at bivariate analysis. You know, how do 2 variables relate to each other? Comparing them in very simple ways. You could do a crosstab or just a simple correlation. And then obviously we move from quantitative to qualitative data, and there are different ways to look at qualitative data: typologies, taxonomies, categories, matrices, looking at patterns, looking at themes. And so those are different ways to analyze data if you're looking at qualitative data. And so that is really your 12-week course in a whirlwind tour. And I'm going to go ahead and unmute everyone and see if anyone has questions. I will post the slides available in your course documents shortly after this session, once I have that recording updated as well. Any other questions? You can download the exam and turn it in by Sunday. You actually can. The exam will be available up until 11:59 on Sunday. So you can download it at 11:59 if you want to work over, the evening. You'll have 4 hours to turn it in. So technically, it's not really due until 3:59 a.m. on Monday. Any other questions? All right, well, hearing none, I'm going to stop the recording. I will check the discussion groups for the next couple of days, so if you do have a question come up, please be sure to ask. But do give me 24 hours at least to respond.